Chemistry.
BAP 7F for rate of reaction.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Syahira Balqis from 5 Cambridge. Today we will learn about Chapter 7, Form 4, the rate of reaction. Stay tuned. First thing first, you need to know the difference between the type of reaction and the rate of reaction. When the question asks you about the type of reaction, you must answer whether the fast and slow. But when it comes to rate of reaction, you must answer between high or low. So next we move to observable and measurable changes for measuring the rate of reaction. Number 1, decrease in the mass of reactant, increase in the mass of product, increase in volume of gas release, formation of precipitate as a product, and change in temperature, pressure, and color. Next, how to calculate the average rate of reaction? In the first calculation, you must to know that average ROR is equal to overall ROR. It means it concludes the whole experiment. For the second calculation, the reaction is just for T seconds. If the question say it is in the first 2 minutes, so you must to calculate 0 to 2 minutes. Next, we move to the third calculation. If the question says in the second minutes, you just have to calculate in the first minute to the second minute. For instantaneous rate of reaction, you must plot a graph and measure the gradient tangent. There is a step to calculate the instantaneous ROR.
1. Draw a tangent to the curve. 2. Use the tangent to complete a vertically angled triangle.
The triangle can be drawn into the various size. The bigger the size of the triangle, the more accurate to determine the gradient tangent. So the last step, you must to calculate the gradient of the tangent to the curve. This is an example equation. There are 5 factors that affect the rate of reaction. That is
Size of reactant, concentration,
Temperature.
catalyst.
for the size of reactant, the smaller the particle, the fastest reaction to occur because it increases the total surface area. For the concentration, the higher concentration, the higher the rate of reaction because it increases the number of particles per unit volume. Next, the higher the temperature, the particle will move more often because it increases the kinetic energy. Lastly, the catalyst. As long as the catalyst is added, the reaction will be much faster because it provides enough energy to overcome activation energy.
Activation energy.
But wait, what is the activation energy? It is the minimum energy necessary for a specific chemical reaction to occur. Next, we will learn about the shape and curve of the graph. This is the graph for the rate of reaction. First, you must take a look at the first part, concentration and ROR. But the second part is for the mole. So now I will teach you how to make a line at the first part and the second part. So for the concentration, you can see at the table 0.2 and 0.1. Experiment 1 has bigger concentration than experiment 2. So the graph for experiment 1 is higher than experiment 2 at the first part. Experiment 1 is more concentrated than experiment 2. To calculate the mole at the second part, you have to use a formula N equal to mV per 1000. So now you can see the mole for experiment 1 is higher than experiment 2. So the line for experiment 1 is higher than the line of experiment 2. So now you have to write an experiment 1 in line 1 and experiment 2 in line 2. Don't forget to write a number of mole of each experiment.
You whisper, good morning.
So it is the end of our video. I hope that all of you will understand this topic because it is so easy peasy. And bye!